let's see, what have we done? We've done the rational root theorem. We've talked about upper and lower bounds. We've talked about Descartes' rule of signs. So I'm going to put a problem up here, and we're going to try and work our way through this problem and find all the real zeros. And if it has any imaginary ones, we're going to try and find those too for this polynomial. Alright, so f of x equals 2x to the fourth plus x to the third minus 14x squared plus 5x plus 6. Okay, so that's our problem. Got a problem, go solve it. Yeah. Okay, where do we start? Not with crying and tears. No. P's and Q's. P's and Q's. P's and Q's, please. Alright, so what are all the factors of my P's right here? And what are all the factors of Q? Okay, so P over Q will be 1, 2, 3, 6. Is that it? No. There's 1/2. I don't need to do 2 over. Is that it? 3/2. Is that it? 1/3. What we're doing is we're putting all of these over all of these. Okay? So we did 1 over 1, 2 over 1, 3 over 1, 6 over 1. And then 1 over 2. There's no need in putting 2 over 2 because it's 1. 3 over 2. And 6 over 2. But 6 over 2 is 3, and we already have 3 listed. So that's how we get our P's and Q's. Okay? So those are all of our possible rational roots, right? So how many of them do we have to choose from? 12. Okay, so we could, there's only 12. There's 12. We could just dive in and start doing some synthetic division and trying to find our zeros. Or we could maybe try and rule some of them out using upper and lower bounds if we wanted to. Do we want to rule some out, or do you just want to dive in? Dive in? Let's at least do Descartes' rule of signs so we know how many we're looking for. How about that? Descartes' rule of signs. Positive is 2 or none, right? Okay. Descartes' rule of signs says how many ever sign changes there are in the original problem, you have that many positive roots, or that many minus ones, which is 2. And we have 2 sign changes, from a positive to a negative, and from a negative to a positive. So for positive roots, it's 2 or none. So if we find 1, we know we have another one out there somewhere. Because there's 2 positives, or there's 1 positive. And here's something else that you can do. If you're working along and you find 3 positive roots, guess what? You're wrong. Yeah, because there's not 3. There's 2, or there are none. Okay? Now for negative roots, you put a negative in for all these x's and see if the signs change. Okay? The sign's not going to change here. That one will go to negative. That sign doesn't change. Alright, so positive to a negative, negative to a positive. So for negative roots, there are also 2 or none. Now, when we say a sign change, we don't mean from here to here. That's not what we're talking about. It's not from here to here, okay? It's this direction. Sign changes that way, okay? That's what we mean when we say a sign change. I'm going to say there are 4 solutions to this one. I'm thinking that there are probably 2 positives and 2 negatives. That's what I'm thinking. Okay? I'm going to just guess that. 2 positives. Because there has to be 4 answers. Real or imaginary. Since it's 2 and 2, I can't think that's okay. Alright, so, since we're not going to do upper and lower bounds, let's pick a number. What number do you want to use first? Negative 2, okay. I'm using negative 2. Bring down a negative, or bring down a 2. Times negative 2 is negative 4. Negative 3. Positive 6. Negative 8. Positive 16. 21. Do I need to go on? It's not a root. Okay, so negative 2 is out. Who chose that? You're fired. Because it didn't equal 0. The remainder was not 0. It's not a root. Okay? It's the remainder, it didn't equal 0. It's not a root.
Negative 3.
Negative 3? It is 1? Okay, let's see. 2, negative 6, negative 5, 15, 1, negative 3, 2, negative 6, 0. We found a root. There's one of them. Here's something else, though, that we can now look at. Okay? Looking at your P's and Q's, this is now a reduced polynomial, right? The last number is now 2. So of our rational roots, possible rational roots, we can knock out 6. Okay? 6 is gone. Because 6 came from up here. This one is a reduced form of that. Okay? It's not going to work anymore. If it didn't work in this first one, where 6 was actually the last number, it's not going to work. 6 doesn't work. Because we could rewrite this and do all new P's and Q's, and they're going to be the same P's and Q's as these, except what can we leave out? Not just 6. We leave out 3, right? And the 3 halves. Yeah, those are out. Those are gone. So use your answer to help you eliminate some of your choices. Okay? Alright, so we've got it down to a cubic. If we can do synthetic division one more time and find something, then we'll have it down to a quadratic that can be factored. Okay? So we need to pick some of these, or one of these, and test it out, see if it works. Negative 1/2 and 2 works. Alright, well, I've already written negative 1/2, so we're going to go with that one. So I don't want to waste my ink or eraser. Yeah, so that's 2. That's going to be negative 1. that's a negative 6, positive 3, positive 4, a negative 2, and 0. So negative 1/2 is one of our roots. Yes. Synthetic division. What I'm doing to get these numbers, I bring down the first number. It's just synthetic division. Bring down the first number, and then you multiply and put your answer here. Add, multiply, put the answer here. Add, multiply, put the answer there, and add. It's just multiply, add, multiply, add, multiply, add. Yep. Okay, now this is a polynomial itself. What polynomial is that? Tell me what to write. No, I want this as a polynomial.
Oh, x and 2x squared minus 6x.
Okay, great. Alright. So I need to factor this. I'm looking for zeros, okay? So I have to factor and solve this. I'm looking for the roots. You can if you want, yeah. So you can just have x squared minus 3x plus 2. And what are two numbers that will multiply to equal 2 and add to be negative 3? If that's the case, then my other two roots are 1 and 2. Yeah. So all the roots are negative 3, negative 1/2, 1. I will not lie to you. It is a long process. But it's not a difficult process. Everything that you're doing here, we've done. It's just you have to put it all together. Okay? It is a long process. This is where we have our perseverance and problem solving. Because it does take you a minute to get to the end. Okay? And that's without distractions. With distractions, it takes you even longer. Alright? So I'm going to put another one up here and just let you get started on it. I'll jump in just a minute, but I want you to at least get started on it. I'm gonna get a pretty easy one to start with. How about that? 3x to the third. Alright. How about P's and Q's? What are all my possible rational roots? And then anybody do any sign rules? There has to be how many positives? At least one positive and what? 2 or 0 negatives, okay? Did anyone find an upper or lower bound so we can knock out some of these? You did? There's 1? Oh, awesome. Okay. Did 1 work?
Yes.
Is 1 a 0? Okay, so let's do 1. That comes straight down, and then you multiply, and put your answer there. Add, multiply, put your answer here. Add, multiply, put your answer here. There you go. Okay. So this does just give us a quadratic right here. But with the fact that these are all positive, it can also tell me that I found my one positive root. So I can stop looking at positive and focus on the negative number. That's my upper bound, is 1. That's another way I know there are no more positive roots. 1 is the upper bound. That's it. Now I could try like 1/3 or 2/3 or no, like 4/3, but there's no reason to because I did Descartes' rule of signs and it said there's one positive root and I just found it. It's 1. Okay? So at this point, if you really dislike synthetic division over factoring, you can start putting some negative numbers in here and try to find what the other two roots are, but they're going to be fractions, or at least one of them is, because you've got that 3 in the front. So at this point, I put over here. And my two numbers that are going to multiply to equal 24 and add to be 14, 12. Factor by grouping. Take out an x, I have 3x plus 2. Take out a 4, 3x plus 2. So the other zeros, let's see, there's 1, there's -4, and there's -2/3. There we go. How backwards? Like,
Did synthetic division of -4 and 3x squared
oh,
minus
that's
4x
fine.
minus 2.
Yeah, that's fine. That's fine. You got the same answers, right? Yeah, that's fine. That's perfect. And that just shows you that those are the zeros. No matter where you start, if you do the math right, you're going to get the same zeros. Okay? So it doesn't matter where you start, you're going to get the same zeros. Is this a difficult process? No. Is it time consuming? Yes. Do not confuse time consuming with difficult. That's what lazy people do. Lazy people confuse time consuming with difficult. Time consuming and difficult are not the same thing. Okay? Don't confuse the two. It is time consuming, but it's not difficult. You know how to do this. It's just a matter of actually doing it. Okay? But you know how to do this. Alright.
So